Welcome to another episode of the Pharmaceutical Calculations Solve Along. In this video, we are going to take a look at how to solve dilution of acid concentration type questions, and I'm going to emphasize a very important trick that will help you do these calculations relatively easily. But before we begin, I just need to give some overview on what really pertains when it comes to dilution of acids. So when you talk about dilution of acids, you actually encounter this situation where your concentrated acids are expressed in terms of percentage weight in weight. And that is significant because when you talk about percentage weight in weight, it's one of the ways in which you express concentration, and typically what you have is some quantity in grams divided by 100 grams of preparation. So that's the definition of percentage weight in weight. Now the issue arises that normally we tend to use a more diluted form of the acid. And in this instance, the strength of an official diluted acid is expressed as percentage weight in volume. Okay, so here you're actually going to have some quantity in grams divided by 100 milliliters. So you notice that the units are not consistent, and that is one of the things that makes some of these calculations a little bit more complex. But the way you get around that is to focus on this idea that whenever you want to do this kind of computation, you need to include the specific gravity. So it's always necessary to use the specific gravity of the concentrated acid when you are calculating the volume that you need to prepare of your diluted acid. And the way you capture that mathematically is basically to use this equation. So here, what we are saying is you can basically convert percentage weight in weight to weight in volume. And you use this simple relationship. So percentage weight in volume of concentrated acid is equal to the percentage weight in weight of the concentrated acid times the specific gravity. So when you do this, you are able to convert the percent weight in weight to weight in volume. And we are going to make use of this important information when we talk about how you can easily solve these types of dilution of acid type questions. So what we'll do now is we'll take a look at a few questions, and we'll start off with the first question we'll actually use to illustrate how you solve these type of questions from first principle, and we will juxtapose that with the approach where you first convert percentage weight in weight to weight in volume, and then use the algebraic approach to solve the question. So let's go ahead and take a look at what that will look like. And so the first question says, how many milliliters of 37% weight by weight hydrochloric acid having a specific gravity of 1.2 are required to make 1,000 milliliters of diluted hydrochloric acid 10% weight by volume? So here, the first thing that we notice is that we have a concentrated acid, which is 37% weight in weight. We have the specific gravity, and we want to make a 10% weight in volume. So notice you have weight in volume, that's a diluted acid, weight in weight, concentrated acid. And so from first principle, the way to work is you want to answer a number of questions. The first question is, how much pure HCl is in the 10%? That's the first question we want to answer. So how much pure hydrochloric acid, so HCl, is in the 10% in this quantity. And the way we do that is we take the percentage concentration here. So 10% implies you have 10 grams in 100 milliliters. But notice we want to prepare 1,000 milliliters. So we need to figure out how many grams will be needed for the 1,000 milliliters. So we can go ahead and solve for x, which is our unknown. And x will be equal to 10 grams times 1,000 milliliters divided by 100 milliliters. Now, if we do this correctly, then we end up with 100 grams. Okay? So this 100 grams represents the amount of pure HCl that is present in the 10% solution. Okay? So 100 grams represents the amount of pure hydrochloric acid in this 10% solution, the 1,000 ml of the 10% solution. Now, the next question that we need to ask is how much of the concentrated acid do we need to supply this 100 grams? That's the next question we need to answer. And the way we do that is we take that percentage to the 37, which implies that you have 37 grams of hydrochloric acid in every 100 grams. So notice the units. And we want to figure out how much of this solution we need to supply this 100 grams. So the 100 grams goes to the numerator on the right hand side of the equation, and then the x goes in the denominator. So we can go ahead and solve for this x here, which is our variable, and that will be equal to 100 grams times 100 grams divided by 37 grams, and that gives you 270.3 grams. 270.3 grams. Now, by the way, if you are watching this live and you have questions, just put them in the chat. And if you happen to be watching the replay, then just leave your questions in the comments and I will address them as soon as I see them. So, to continue, what we have right now is quantity in grams, but we need the volume because question is saying how many milliliters. So the third step here will be to use the specific gravity information and basically the density information to convert the mass in grams to volume in milliliters. So the way we will do that is we will recall that specific gravity is equal to the density of substance, in this case HCl, divided by the density of water, which is H2O. And what that would imply is that the density of HCl is equal to the specific gravity times the density of the water. So specific gravity is 1.2, which was provided in the question. And the density of water is 1 gram per milliliter. So the density of the HCl is 1.2 grams per milliliter. So normally, if your reference liquid is water, then the density has the same numeric value as the specific gravity. You just have units when you talk about density. So now what we can do is recall that density is mass over volume, and we want the volume. So volume is mass over the density. Okay? So the volume that we are looking for is going to be equal to 270.3, which is grams here. That's from here, divided by the density, which is 1.2 grams per milliliter. So the grams cancel out. And what you have is 225.2 milliliters. So that will be your volume. That right there will be your volume. Okay, that's the answer. So notice in terms of recall or the high points from this conversation is you first need to determine what the pure key phrase pure HCl is present in the 10% weight by volume. Okay, and then once you figure that out, we had 100 grams, but we now need to supply that using the 37% weight by volume. And that's what happened at this point. We determined the mass, but we need volume, so we use density to connect mass and density to give us the volume. So the answer is 225.2 milliliters. So this is how you solve the problem from first principle. But now, let's just take a look at how you solve this same question using the approach that I was alluding to earlier in the first slide. And you tell me which one you prefer. Okay, you can leave your comments in the chat or leave your your comments in the comment section. So, same question, but we're going to make use of the idea or the trick where we're going to convert this percentage weight and weight to weight and volume, and then use the algebraic approach. Algebraic approach is C1 Q1 plus C2 Q2 equals C final Q final. That's where we are headed. Okay, so you have two components. This is concentrated, okay, and we are making a dilute preparation. So what that means is C1 Q1 plus C2 Q2, because you need to mix your concentrated down with some diluent, which is normally water in this case, to give you the lower concentration. So we know what C2 is, that's your diluent, so it has 0. Q2, we don't know what it is, so Q2. C final is going to be the 10 weight by volume, and then your Q final is actually 1000 milliliters. Now for C1, we know what the concentration is in weight by weight, but we don't know the quantity, so we call that Q1. Now instead of putting down the concentration in weight by weight here, the number that will go here will be the value after we've converted the weight by weight to weight by volume. Okay, so let's see how that works. Now, you would recall from the first slide that the equation is percentage weight in volume of the acid is equal to percentage weight in weight of the acid times specific gravity. So here we'll take the 37% and multiply that by the specific gravity, which is 1.2. And that gives us 44.4. Okay, so we just moved from the space of weight by weight to weight by volume. And so our concentration actually is going to be 44.4% weight by volume. Okay. So now our work becomes really straightforward and easy. What we're going to have is C1 to be 44.4 times Q1, which is what we are looking for, plus C2 Q2, which C2 is 0 times Q2, and that should be equal to your 10% times 1000. Now, 0 times any number in this universe will give you 0, so that goes to 0. And so what we have is 44.4% being equal to times Q1 being equal to 10% times 1000 milliliters. So we can go ahead and solve for Q1 by dividing both sides by 44.4%. So Q1 equals 10% times 1000 milliliters divided by 44.4%, and that will give us essentially 225.2 milliliters, which is exactly the same answer we had in the previous approach. Now, experience has indicated that most students struggle with the first principle approach, the one that we just looked at, and find this strategy much more palatable and very easy to actually use. And so this is a useful trick that will help you deal with all types of questions where you have to convert the concentration from weight by weight to weight by volume. And it's particularly applicable when you're talking about acids because you always see that. All right, so to summarize, the thought process is you first make sure that you convert the weight by weight to weight by volume using this equation. Percentage weight by volume equals percent weight by weight times specific gravity. And then you go ahead and use the algebraic equation, which is C1Q1 plus C2Q2 equals C final Q final. And everything becomes algebra. Okay. All right. So I don't see any questions in the chat. Let's take a look at another question. And this time we have all the background to know how to deal with this type of questions. So you can solve along from the comfort of your room just to make sure that you understand these type of questions very clearly. So second question says, calculate the volume of 61.3% weight by weight perchloric acid required to prepare 2000 milliliters of 36% weight by volume of perchloric acid. The specific gravity of 61.3% weight by weight perchloric acid is 1.67. All right, so here we could go straight ahead and use the trick I talked about. And what that would look like is we have two components. We have a concentrated acid, perchloric acid, 61.3%, and we want to make something less concentrated or more diluted, and that's 36%. So what that would imply is you have your C1Q1, but we need to dilute it down, so there's a second component. And the reason I like to always put the second component is I notice that if you just put a C1Q1 equals C final Q final, most people don't really conceptually understand that you're mixing two things together. So that's why I like to put that term there, the C2Q2. But anyhow, that gives you C final Q final. And we can identify what our parameters are. So C1 here is actually going to be the 61.3% weight by weight, but we'll just leave that blank for now because we are going to convert the weight by weight so that it matches up with the weight by volume. We are interested in finding Q1. We don't know what that is, so we keep that the same as Q1. Now our C2 is going to be more likely water or a diluent which has no perchloric acid in it by implication, so the concentration will be 0. And then Q2, we don't know that, but that will also be Q2. And C final is going to be equal to the 36% weight by volume. And your Q final is 2000 milliliters. So the first thing we want to do here is actually do the quick conversion. Okay. So we'll make use of the equation that says percent weight in volume of the acid should be equal to percent weight in weight times the specific gravity. So we take the 61.3% weight by weight and we multiply that by the specific gravity, 1.67, and that basically gives us 102.7%. So we just put right here for completeness 102.7%, but that's weight by volume. So our units are consistent and we can go ahead and put that information into the original equation here. Okay. So C1 is now going to be equal to 102.7 times Q1 plus C2, which is 0, times Q2, and that's going to be equal to 36% times 2,000 milliliters. So 0 times any number is 0, so this goes to 0. And then what we are left with is 102.7 Q1 being equal to 36% times 2,000 milliliters. So we can go ahead and solve for Q1 by dividing both sides by 102.7%, and Q1 will be equal to 36% times 2,000 milliliters divided by 102.7%. So in which instance, your Q1 after simplification will be equal to 703.3 milliliters. So this question allowed us to reinforce the concept. The trick or strategy here again is to first convert the percentage weight in weight to weight in volume, so that you can go ahead and use the C1 Q1 C2 Q2 equals C final Q final equation, and everything then becomes algebra. So this is a key step, okay, and this is where the trick comes into play, okay, converting from percentage weight by weight to percentage weight in volume, making use of the specific gravity. Now, up till now, what we've done is basically determine the volume of the concentrated preparation in milliliters, okay? But let's look at a slightly different twist on this type of question and see whether we can make use of the same understanding to address it. That way we are sure that we've expanded our thought process and how to deal with these type of questions. Now, once again, if you have any questions, just put it in the chat box if you're watching this live. And if you're watching the replay, then leave your questions in the comments and I will address them as soon as I see them. Now, if you like this type of content, just go ahead and click the like button. And if you don't want to miss this type of live session, then subscribe and click the notification bell. But let's take a look at a slightly different question. Same principle concept, but here, instead of simply finding the volume of your concentrated acid, we actually want to use that information to determine the final concentration of a preparation, okay? So let's see how it works. Same principle, but different objective or task here. So the question actually says, a pharmacist mixes 100 milliliters of 38% weight by weight hydrochloric acid with enough purified water to make 360 milliliters. If the specific gravity of hydrochloric acid is 1.2, calculate the percentage strength in weight by volume of the resulting solution or resulting dilution. So here again, you have two things you're mixing together, the hydrochloric acid and purified water. You're mixing the 38% HCl with purified water. And so two components implies that C1 Q1 plus C2 Q2 equals C final Q final. Okay? And we can put down what our components are. So C1 Q1. Q1 is basically giving us 100 milliliters. And that's from here. And your concentration is 38% weight by weight. But since we're looking for a final concentration in weight by volume, we want to go ahead and convert the 38% weight by weight to weight by volume. And that's the value we'll put down here. But we'll come back to that in a minute. The concentration of purified water has no hydrochloric acid. So the concentration there will be 0. Q2 we don't know, so that will be Q2. And C final, we actually don't know this time around. So C final is C final. And Q final is giving us 360 milliliters. So the difference between this question and the previous two questions is this time we're looking for C final. And in those two, we had already been given what C final is. But the main task here, once again, is to go ahead and convert percentage weight by weight to weight by volume. So we make use of the equation percentage weight by volume of the acid, concentrated acid, is equal to percentage weight by weight times the specific gravity. And that is equal to 38% weight by weight times the specific gravity, which is 1.2, and that is equal to 45.6% weight by volume. So the value that will go for C1 in this place to make our table complete is 45.6% weight by volume. Now, we have all the information we need to put it back into this original equation to solve for C final. And so the way that will look is we will take C1, which is 45.6% times Q1 plus C2, which is 0, times Q2, and that is equal to C final, which we do not know this time, times Q final, which is 360 milliliters. So 0 times any number is 0, so this goes to 0. And you have 45.6%. But by the way, Q1 is actually 100, so we can multiply that by 100 milliliters. And that should be equal to C final times 360 milliliters. So we can solve for C final by basically dividing both sides of the equation by 360 milliliters. And that would imply that your C final is equal to 45.6% times 100 milliliters divided by 360 milliliters, and that would imply that your C final is equal to 12.67%, and this is definitely weight by volume. All right, so that's how you go about solving this type of question. So same principle, but this time you're looking for the final concentration instead of the quantity of the purified acid, of the pure acid. Now let's go ahead and do one more and then we can wrap up this session. So here the question actually says a total of 375 milliliters of concentrated hydrochloric acid having a specific gravity of 1.16 is used to prepare 1500 milliliters of 20% weight by volume hydrochloric acid. What is the percentage strength weight by weight of concentrated hydrochloric acid? So here we have a slightly different twist on the question again. It's the same principle, but a different twist. And the strategy here is we're going to first go ahead and find what the concentration of the acid is in weight by volume. And then we'll go ahead and convert that value to percentage weight by weight using the equation that we've been utilizing throughout the whole series or the whole solution. So that's, we're going to work in backwards, right? Because we are looking for percentage strength weight by weight. So what that would look like actually is that you start off with your algebraic equation C1 Q1 plus C2 Q2 equals C final Q final. And in terms of concentration, we don't know what C1 is because that's our concentrated preparation that we are looking for. That's this concentration that we're looking for. Q1 is going to be equal to 375 milliliters. That's from right here. C2 is going to be equal to 0. Q2 is equal to Q2. We don't know what that is. And C final is actually giving us 20% weight by volume, and Q final is actually equal to 1500 milliliters. So we can go ahead and substitute all this information into the equation. We'll then use that to find what C1 is, but that concentration will be percentage weight in volume, weight by volume, and we'll then convert that to weight by weight. Okay, so we will have C1 times 375 milliliters plus 0 times Q2 should be equal to 20% times 1500 milliliters. So 0 times Q2 goes to 0, and then we'll have C1 times 375 milliliters being equal to 20% times 1500 milliliters. We want C1 by itself, so we divide both sides by 375 milliliters. So C1 is going to be equal to 20% times 1500 milliliters divided by 375 milliliters. So if we do the math, it's going to go ahead and give us 80%, but that is weight by volume, and we need it to be in weight by weight. So the equation, once again, is that would allow us to do the conversion is percentage weight by volume for the acid, concentrated acid, is equal to percentage weight by weight times the specific gravity. Now, because we're looking for percentage weight by weight, we can rearrange the equation to give us percentage weight by weight being equal to percentage weight by volume, or weight in volume, divided by specific gravity. So what we can do now is we can basically go ahead and put all our information into this equation. So the percentage weight by weight is equal to the 80%, which is what we calculated here, divided by the specific gravity, which is 1.16. Now, if you go ahead and do the math here, that gives us 68.97%. So basically, that's how you go ahead and use the same principle to solve a variety of scenarios. We looked at 4 different scenarios in which you can actually apply this concept when it comes to doing dilutions involving acids. Okay, key thing, or the main trick, is whenever you have percentage weight in weight and weight in volume, use this equation to convert from one to the other. And that will make your life very, very easy, so that you can basically go ahead and use the algebraic approach to solve your dilution problem. All right, so we're going to stop here, and we'll take a look at something else in the next video. Thank you so much for watching, and I will see you in the next video.